Okay, welcome back to the today's class. We will be seeing about electrodynamo type wattmeter and energy meter. Okay, these two are two different instruments which are being used to measure power and energy. Okay, first we will be seeing about electrodynamo type wattmeter. Okay, wattmeters are basically used to measure the amount of power delivered into the load or the power consumed by the load. Okay, if you are connecting a fan in the AC supply, the fan will consume some power. Okay, so how much power the fan consumes, you are going to measure. Then you need to have a wattmeter, and this wattmeter will show you how much watts, that is 10 watts or 20 watts or 40 watts or 60 watts, how much watts the fan is consuming. Okay, in normally the ceiling fans in our homes will consume 40 watts to 50 watts. Okay, some old fans which are very old will consume about 60 watts. Okay, this is the internal diagram or circuit of the wattmeter. Okay, in this you will be having two coils. One is current coil and another one is pressure coil. Okay, you will know the formula for finding the power. What is the formula for finding the power? C is equal to V into I. This is for DC. Okay, for AC supply, CAC. Okay, let us name it as CDC. Okay, CDC. And for AC supply, which will be equivalent to VI cos pi. Okay, cos pi. So you can see the multiplication of voltage and current for DC and the multiplication of voltage, current and power factor for AC gives you the power present or delivered or consumed by the load. Okay, so here you can see there are two coils. One is the current coil, okay, and the another one is the pressure coil with a resistance. Okay. Here you can see the current coil is going to measure the amount of current I. Okay, the amount of current I flowing in the circuit. Okay. Similarly, the pressure coil PC is going to measure the amount of potential difference present in between the supplies. Okay, so you can see the current coil is connected in series to the load. This is the load, this is the fan you are going to measure. Okay, the power of the fan you are going to measure is known as load. Okay, so the current is supplied through the current coil and it is entering into the load and it is being back out. Okay, and the current coil is going to measure the current which is entering into the load. Then you can see the pressure coil, and here the pressure coil is going to measure the applied voltage. Here the applied voltage will be from this end to this end. Say 230 volt is being applied. Then the pressure coil is connected in parallel. Okay. Here you can see the current coil is in series, whereas the pressure coil is connected in parallel with the help of a small resistor. Okay. This pressure coil will measure the voltage, and the multiplication of the current and the voltage which is being measured will give you the power. Okay, for AC you can find the power by multiplying the current and the voltage, but for for DC you can find the for DC you can find the power by multiplying voltage and current, but for AC you need to multiply an extra parameter which is cos pi. Okay, so this cos pi has to be found. How you can find the cos pi? This is the internal structure of the electrodynamo type wattmeter. Okay, here you will be having two coils. Okay, which is the fixed coil. Okay, there are two fixed coils and another one is the moving coil. Okay, here you can see The fixed coil is going to carry the current into the load. Okay, this current is going into the load. So the fixed coils are nothing but the coils which are used to measure the current flowing into the load. So these coils, fixed coils, are known as current coils. Okay. Whereas the moving coil, this one is the moving coil, and this moving coil is going to measure the voltage because it is being connected in parallel with the help of a resistance. Okay. So this moving coil is going to measure the voltage across the terminal. Okay. So this is going to measure the voltage, and you can see the pointer is present here, and the pointer will show you the value of power in watts. Okay. Here you can see there are two coils. Okay, one is fixed. Okay, one is fixed, and another one is the moving coil. Okay, another one is the moving coil. Okay, another one is the moving coil. Okay. So if you supply a voltage and there is a load is connected, then the current will be flowing through the fixed coil. Okay. Then what happens is there will be a magnetic flux which is being produced by the fixed coil as well as the moving coil. Okay. These two magnetic fluxes, okay, there will be two magnetic fluxes. These two magnetic fluxes will be produced, and this magnetic flux will interact with the pointer and helps to move the pointer in the graduated scale. So since these two fluxes are added up, so while the fluxes are being added up or being get into touch, what they will happen is they will going to measure the cos phi. Okay, so you know the formula P is equal to VI cos phi. Okay, VI cos phi. Here the voltage is being measured with the help of the moving coil or the pressure coil, and the current is being measured with the help of the fixed coil. Okay, and the power factor cos phi is going to measure with the help of the fluxes generated between the two coils. Okay, name it as pi A and this be pi B. So the vector sum of the total flux phi will be equivalent to pi A plus pi B. So this flux which is present here is the interaction between the two fluxes pi A and pi B which are produced by the current which is flowing here. One is the IL current, and here also there will be a current present here. Okay. So these two currents create two fluxes pi A and pi B, and these two fluxes will add up together and create the flux phi, and this flux is being used here, and it is being multiplied with the voltage and current values to get the power value. Next we will be seeing what are all the errors present in the electrodynamo type wattmeters. Here you can see for lagging phase angle, of the load circuit, the angle phi dash between the voltage coil current IP and the current coil current I becomes less than the actual flux. Okay. Which represent, you can see this is the actual voltage supplied and this is the actual current delivered, since there is a lagging phase angle, that is a lagging power factor. If there is a lagging power factor, if you are going to connect a voltage coil, going to connect a inductive load to the wattmeter, what happens, the inductive load will produce a lagging phase angle. This lagging phase angle will make the lagging power factor. So the current which is being flowing in IP, that is the voltage coil current, will lag by an angle of phi. So this is known as the lagging power factor. So the reading of the wattmeter is proportional to cos phi dash and not cos phi. So you always know you need to have Vi cos phi. Okay, but you can see the power which is being measured by the wattmeter is for cos pi dash and not for cos pi. So the wattmeter reads a higher value. Next, when for leading phase angle, it will be inverse. So what happens here is you can see the proportional value is for cos pi and it is not cos pi dash. But what happens here is due to leading power factor, the amount of current which is being measured will get increases to a very large extent than the normal value. So the wattmeter starts to read a lesser value. When it is a lagging power factor, the wattmeter reads a higher value. For a leading power factor, the wattmeter will read a lesser value of power watt. Okay. Next, there is another one error, which is voltage coil capacitance. There will be some amount of capacitance on the voltage coil. So, this voltage coil capacitance will create you some error. The effect of capacitance on wattmeter reading is opposite to that of inductance. So, this effect will be completely opposite to the effect of inductance, and the wattmeter will not read the accurate value. Let's move to the next type of error. Okay, the next type of error is mutual inductance between the two coils causes error in measurement. Okay, since there are two coils, then there will be a mutual inductance. So this mutual inductance between the two coils causes one error. Such errors are quite low at the power frequencies. Since the power frequencies, which is 50 Hz, this error is negligible. When the frequency becomes increased, then this error becomes predominant. And there is another one error due to eddy current. When AC current flows through the coil, an alternating magnetic field is set up, and this magnetic field induces a eddy current. These currents produces a field of their own. This changes the magnitude of the phase angle. You know the phase angle pi is being measured for cos pi. Since there is eddy current, this eddy current will set up another one magnetic flux, and this flux will changes the correct phase angle pi, and this will causes an error in measurement in wattmeter. The last type of error is stray magnetic field. Here the stray magnetic field represents a magnetic field is present in the earth. It is known as gravitation. Okay. So this gravitational pull or the earth's magnetic field may affect the wattmeter readings. So the wattmeter has air core coil. The magnetic field is weak and can be influenced by stray magnetic field. This may cause errors, so the instruments are shielded against the stray magnetic field effect. So all the wattmeters are shielded instruments and none of the magnetic field outside the wattmeter can enter into the wattmeter measuring instrument. Next, we are going to measure, study about energy meter. Okay, what is the difference between the wattmeter and energy meter? The main difference between this wattmeter, you are going to measure the power in watts, whereas in energy meter, you are going to measure the power in watt hour. Okay, here the time is being added with the power. Okay, watt into hour gives you watt hour and it is measured by energy meter. Okay. Only watt, only power is measured by watt meter. Here you can see the complete construction of the energy meter. So the main components of energy meter is the driving system. For the driving system, you can see there are two bearings. Okay, this is one bearing, and the upper end there will be another one bearing, and this one is the shaft. In the shaft, you will be having a aluminum thin disc. Okay, and here you can see the shaft is connected in the disc. Okay, this disc is very free to move. Next, you will be having the moving system. Okay, this shaft is to be rotated. Okay, how this shaft is being rotated with the help of a moving system. What are the moving system present here? The moving system present here is the two things. One is the pressure coil and the current coil. You can see this is the AC supply. Okay, this is the AC supply, and this is the load. Okay, you are going to connect the load. You are going to connect the load, and here you are going to connect another one end of the load. Okay, here similarly of wattmeter, you are having a current coil at the bottom end. See, you are having the current coil at the bottom end, and then you are having a pressure coil or the voltage coil at the upper end. Okay, now there will be two fluxes produced in the pressure coil. One flux is present in the pressure coil and the other flux is present in the current coil. Okay, these two fluxes will interact in the aluminum disc and make the disc to rotate. So moving system is nothing but the pressure coil and the current coil. The braking system. Okay, to break this disk movement, once it is being rotated, the energy is being measured. Okay, if the current goes away, then the inertia present in the disk will tend to rotate the disk for some time. So to break the disk when there is no current, you need to have a braking magnet, and the disk will have a hole here. When the hole reaches the end of the braking magnet, at once the disk will stop. If there is no supply in the pressure coil and the current coil, there is no current. Okay. Next one is the registry and counting system. At the end of the shaft, okay, there will be a numerical register where the numbers will be moving one by one to count the amount of units consumed by you. Okay, the same principle is being used in the energy meter also, but the only one difference is the disk will continue to rotate till the supply goes off, and this disk rotation is being connected to the shaft, and this shaft is connected to the registry system, which will be equivalent to the speedometer. Okay, you may see the amount of kilometers run in your bike or vehicle. So this will increasingly run one by one, and it will register the number. Okay, similar that the registry system will be present in the upper end. Okay, you can see this one is the mechanical wattmeter present. Okay, and this one is the energy meter which you can see in your home. Okay, and this is the thin disk. Okay, and here this one is the registry system. Okay, since the disk rotate, the registry system will count one by one. Okay, but in watt, you will show the watt. If the supply goes off, the pointer reads 0. Okay, but here if the disk rotates, the registry system will read. If there is no supply, the registry system will not count back to 0. Okay, it will stay at the position. Okay, so this is the difference between the watt and energy, watt hour. Okay, and we are also having the digital watt meters and digital energy meters. Now we have replaced this type of energy meters with electronic types of energy meters. The only purpose of replacing this mechanical energy meters into electronic energy meters is you know well about the supply. The disk rotation is due to the magnetic field created by the pressure coil and the current coil. Okay. Since this complete system works in magnetic setup, If you keep a strong magnet outside the meter, the disk rotation will be stopped and there will be a loss for the energy producer, for example TNEB. So there will be a loss for TNEB. To avoid this, they have changed to digital energy meter. Here the measurement is made through digital ammeter and digital voltmeter. There is no role for magnetic field. So if you place a magnet in the digital energy meter, it will not affect the energy meter and the readings will be very accurate. Okay. These are all the basics of the electro dynamo type wattmeter and energy meter. Thank you.